Hi, your next challenge is entitled Sort Numbers in Ascending Order. You are to create a function that takes an array of numbers and returns a new array sorted in ascending order from smallest to biggest. Sort the numbers array in ascending order. If the function's argument is null, an empty array, or undefined, return an empty array, and return a new array of sorted numbers. Okay, so they're going to give us this collection here, and we are responsible for returning another collection containing the same values in sorted order. I think that's clear. Ascending order, 1, 2, 5, 10, 50. Feel free to look at these other cases. The more important ones, I think, are when you get null or an empty array. They want an empty array back, so let's be sure to do that. Over to the coding section. Now's your chance to do this on your own. Resume the video once you feel comfortable with your result or if you need help. So the first step, well, you can imagine there's built-in methods for this, and you're absolutely right. You can certainly go right to one of those solutions. I'm going to do that at the end of this video. I thought it might be helpful to work through a sorting problem. It's very common in computer science. When you study it formally, sorting's one of the first topics you sort of get into, the first kind of problems that you solve. And it's a very important process. We work with collections a lot, and so by sorting them, it's very powerful. You can imagine some of those minimum and maximum problems that we did earlier. If you maintain a state of sorted order in your collections, you know right where those values are, and you can leverage that to solve other problems too. The catch with that is that every time the collection is modified, you sort of have to maintain its sorted state. There can be some extra work to be done. If you access the collection in a frequent manner, this can be well worth the trouble of maintaining that sorted order. Anyway, we'll get into it. We'll do our own first. So let's honor their requirement of handling bad input. So if array is equal to null or array length is 0, essentially empty, they wanted us to return an empty array. So let's do that. Then let's get on with the sorting. And I thought there are many sorting algorithms out there. I thought to try and keep this as simple as possible, to just pick one of the easy ones called bubble sort. And so there's a lot of information out there about that. You can look it up. I strongly encourage you to understand. We'll go over a diagram, but there are videos out there where you can kind of see this working in real time that might give a better picture of how it works to you. This is the concept, so just assume we have this size 5 collection of integers, and you're going to take these passes over the collection. You're going to examine 2 elements at a time, starting from the beginning. Think of it as starting at 0 and then peeking at the next element 2, and you're comparing them. So in this case, 5 is greater than 1, so you see how they chose to do a swap here. Then you shift and take the next 2 elements. 5 is bigger than 4, you do a swap again and result with this. You compare these. 5 is greater than 2, there's a swap, and finally you get to 5 and 8. 5 is less than 8, so there's no swap. And this is sort of your result after the first pass. That leads into a second pass, and the reason you have to take multiple passes, I think, is clear if you look at this collection down here, right? Really all we got was 5 in place. If we quit here, there's clearly 4 is greater than 2. This is not a final product. It sort of set up one of the elements for us, but there are 4 others. So you can kind of think of a pass being dedicated to each value. Maybe that helps think of it. So anyway, this result here is what we start with for our second pass. 1 and 4, that looks good. 4 and 2 are out of order, so we're going to swap those. 4 and 5 are good, and again 5 and 8 are good. So this is your result of that second pass. It gets fed in for your third pass, and 1 and 2 look good, 2 and 4 look good, 4 and 5 look good, 5 and 8 look good. And you can see that no swaps took place in this pass, so you can actually terminate early. Notice we only did 3 passes here, but we should have done another one. Oh, it's not that we have to, because there were no swaps, we didn't have to. If you had a swap in here, then you would have taken another pass. But we'll go over that. These passes are for loops, as you might have imagined. We're sort of iterating over this collection, and we're going to have to do it in a nested manner. And I don't think we've done nested for loops, so we'll talk about that. But you can imagine there's kind of 2 loops going on here at any time, right? The actual looping over each of these elements, and then the sort of outer loop of each of these passes, pass 1, or for 0-based indexing, you could pass 0, pass 1, pass 2, that sort of thing. So we'll write some code, and maybe that will help solidify things. But again, there's a lot of information about bubble sort out there. So let's see, we're going to have to iterate over the collection. 0I is less than array length. And I'm doing this -1 because we don't need to go all the way. When we're at any given index, we're peeking ahead 1 slot. So you can think of this as being the end -1, and it's going to include the last value. If we did another loop, we'd be at 8 looking past the array, which would be bad. So we don't need that. And then we're going to increment. So this is sort of like the pass loop that we saw there. And then we need to actually go through each element of the array for each pass. So we're going to have this nested inner loop, as they call it. J is less than array. Same deal with the length. Okay. So then in here, right, the work isn't too bad. We're essentially, if you remember from the diagram, we're just comparing 2 integer values and making sure that one is smaller than the other. If it's not, then we have to do a swap, right? So let's say if array j is greater than array j plus 1. J plus 1 would be the next element, right? If the previous element is greater than that one, we need to have a swap. And to perform this swap, I'm going to make a little helper method for us. Static void swap. And now I'm going to do something maybe that you haven't seen before. I'm going to pass these values by a reference. And that's so I can actually modify them. When you pass integers normally without this ref keyword, you get a copy of the value. So if we modify it, our modification only happens locally and it does not affect this array value that we're going to be using. So we want these values to persist. So I'm passing them by reference. That's what the ref means. And so we can say int temp equals val1. We're going to store the current value of val1. Now we can overwrite val1 because I saved its current contents. I'm going to overwrite it with val2. And then I can say val2 is temp. Yeah. So that will swap values for us. So now if we have this condition, we can simply say swap. And you have to use the ref keyword. Ref j plus 1. Cool. So that's going to swap the values for us. Yeah, let's see. That might cover us. Now we talked a little bit about the optimization, how if no swaps take place, you can sort of terminate early. Remember, we didn't make a 4th pass. because there were no swaps, so we'll handle that. Currently, as written, this will go all the way through, and it would do extra passes even if we had no swaps, which results in just it being less efficient, but it doesn't hurt the algorithm to do passes and not swap anything. That's probably clear. Okay, array creation must have a sign array initializer. Oh, what did I do? Maybe that will work. No, let's do it like this. Program numbers, sort of setting. Not all code paths return a value. Oh, okay. Yeah, we didn't return anything, so let's do this. Int array sorted equals array. We're gonna make, that's right, we needed to make an extra collection, so let's make our own collection. We'll start with array by default, and then we'll sort from there. So instead of modifying the input array, I'm just gonna do it to this local one I created. Once we're through our sorting algorithm there, we can simply return sorted. See how that goes. Okay, cool, there you go, there's some bubble sort. Now, let's do that optimization so we can cut out early, just to clean this up a bit, and you don't want to waste computer cycles, you know, and with a large problem. With a small problem like this, it didn't really matter so much. So yeah, let's do int. I'm gonna make this variable that counts the number of swaps for any given pass, right? This outer loop represents the passes, and so every time I do a swap, I'm going to increment that value. Swaps. And then essentially after this inner loop, after you've gone over all of the elements, right? If we get, you know, no swap, no swap, no swap, that would be like that number of swaps number never got incremented. It would be 0 for that pass, and so we can tell it to break out at that point. So if num swaps equals 0, we can say break, and I think we've talked about break. That will basically jump outside of the containing scope, which is this for loop, this outer loop, and then it spits us out past this, and we'll get to the return sorted. And I just wanted to add something that might be helpful. Console write line, let's call it no swaps for pass. This is another little handy thing you might like, this $sign. Lets me insert variables in there. And instead of printing I, it'll print the value of I. So that's a kind of a handy little thing there. I think I need the system space for that, for console stuff. And then this will just give us a printout. It'll trigger, print this statement. We can see if our tests have any cases where they break out early. Let's add a couple of other prints that might be helpful for understanding how this executes. I'll do it in the swap function itself. How about that? Console write line, swapping value L1 with value L2. Should help us. Yeah, let's copy this and refresh. Don't want to submit this quite yet. So this will show us when the swaps happen. And let's see what this gives us. Unexpected symbol at line 38. What do we do at 38? Oh, sure, closing parenthesis. Cool. So that gives a little bit more understanding. Now what you can do with this is examine your tests. Let's see the first test, what they give us. They give us this collection, 1, 2, 10, 5, 55. So it might be helpful if you copied this text, put it in another, like a notepad file, and then you could look at it at the same time as the console and see and make sure it's doing what you expect it to do as sort of depicted with this picture or whatever reference picture you have. So I want to see if we got one. Yeah, we do see these no swaps for past 5. So that's cool. Some of those triggered. We got a little bit of optimization there. Then we could do console. Complete. And then this /n is going to make a new line character that can sort of put spaces in these sections to sort of break them up logically so you can tell which test is, give you a little gap so you can see them grouped more obviously. And feel free to add all these write statements in here as is helpful to you to give you the picture of what's going on here. So I mean, you could put one in here for on pass I, right? Pass I, you could do it like that. Feel free to omit stuff if it just clutters your output, but add whatever you like to sort of paint the picture where you see the bubble sort happening. So you could put one, add another one, console. Right, line. Comparing value J with value J plus 1. Something like that. So you can see, this guy nice in pass 0. It tells you comparing 1 with 2, no swap. That makes sense, right? We didn't get a swapping statement below it. Comparing 2 with 10, there was no swap. 10 with 50, no swap. All looks good. 50 with 5, ooh, that's a problem. We better see a swap there. And sure enough, we do see a swap happen with 50 and 5. Then you get on to pass 1. And if you didn't like this 0-based numbering, you could just increment that value by 1, but it doesn't bother me. In pass 1, the second pass, comparing value 1 with 2, no swap statement. Good, that's what you'd expect. 1 is less than 2. Same thing for 2 and 10. Oh, 10 and 5. 10's bigger than 5. We should see a swap. Sure enough, you see a swap. And so this is kind of nice where you can see the algorithm working. Again, if some of this is overkill for you, feel free to omit or add more if this isn't enough information for you to understand. Yeah. Looks good. So yeah, hopefully that was helpful. We'll move on to the built-in solution, and you'll get another appreciation for how nice and convenient those are to avoid writing this out all the time. But really, as you're learning, you should understand how to do nested for loops. That's a new concept that you're going to want to get down. And sorting is just such an important and common issue that you really should know how it works under the hood before just resorting to the built-in methods. It's worth your time to learn. You're going to come into these kinds of problems often, and there's not always going to be a built-in solution for you. So it's important that you can make your own when you need to. And if you're going to be in this game for a long time, it's just going to make your life that much easier. So I would strongly recommend going through these. If you want to do some bonus challenges, look up some of the other sorting methods, like quick sort and merge sort and insertion sort. There's a bunch of them. And so, yeah, you'll run into them if you continue to study computer science. You're going to run into all those guys. So that's worthwhile. That said, I think we're good here. Let's move on to the sort of quick solution. Okay. And you know what? There's a couple parts that I liked about that. We can get rid of the swap. Most of this stuff. But I did want cool. Yeah, I did want the input checking still. So then we're going to have a collection. We're just going to make a copy, right? And then, I believe we've used this class before. Array.sort is what I used. I need the system namespace, but you essentially give it the collection and it will sort it for you. It uses a default comparison, but you can tell it how to compare values if you have a custom way you wanted to do it, if you want to do it differently. So I'm just going to give mine an array, and because the default behavior does what I want it to do. So array sort, sorted, we'll say. And then we can simply return sorted, I think. Something like that. And yeah, you can see how much less work that was, and you get an appreciation for this. Once you know how to do sorting problems, you don't need to keep reinventing the wheel every time. You can just go right to these. You could look up how their sort method works. It's probably not bubble sort, so this is probably more efficient than what I did. But yeah, there's the quick way if you want to do that too. So hopefully you came up with something good that worked. You didn't have to use bubble sort. You could have used any sort that you wanted. So I know a lot of stuff there. The nested loops are weird when you first start working with those, so hit me up if there's any trouble. And thanks for watching.